Thank you. Thank you very much. Apologize for kind of coming in unannounced. I actually came up today. Up till today, I'm not familiar with ACAMP or hadn't been familiar with ACAMP. One of the new hires that we've just hired on with our company, his name's Noah Akilu. I don't know if you know him. Anyways, he made me familiar with this. He said, you should come down and see what it's all about. So I just came down today to have a look. I think we're a little farther along in the cycle. We're actually on the market. I just came on board with Synodon as of January, and I'm in charge of doing sales. They've spent the last 8 years developing this product. So, I guess I appreciate the opportunity. I spoke with Carl a little bit, and Carl put me in touch with Ken, and when I came and told Ken what I was doing, and I just was trying to meet him, he said, well, would you happen to have a presentation with you? And I said, I've been selling for 20 years. What are the chances that I have a presentation with you? It's kind of the likelihood of you guys with hair having combs. So anyways, so he gave me a chance to do this, so thank you very much. And I'll try to go through this quickly. I know you've had a long day, so I'll move forward on this. Okay, see if I've got this right. Okay, so what we've developed is a new sensor, a new technology. It's called RealSenses is the name we've given it. And some of the points are, the first 4 points are fairly significant. It's ethane specific, no false positives, and I want to clarify that. We can sense methane, ethane, and propane. We've designed it right now to target ethane because, as you're probably aware, if you're flying over a given area in the field, if there's natural sources of methane leaks or methane coming up from the ground, we want to make sure that there's no false positives. So by looking at ethane specifically, all we need is 1 to 2% ethane in the natural gas, which there currently is in your sales gas. We have the ability to sense it. If a customer wants us to look just for methane, we can just very quickly change there's a reference calibration gas in there. We can change the calibration gas, and we can look specifically for methane. So we've we can do both very quickly, but we try to target ethane to make sure there's no false positives. We don't look at the temperature of the gas. We do not have to pass through the gas. We fly at 1,000 feet, 300 meters, and we can identify a gas plume, the point of the start of a gas plume within 2 meters. So we feel these are kind of differentiating factors that we've developed in this product as we're coming to market here. We too have a good potential. We can take a pretty good stab at calculating a volume, and to our best knowledge right now, the technologies that are out there cannot very accurately pinpoint the volume of a gas leak. They can point out where it's coming out and where maybe the gas is lying, but they don't have the same ability to calculate what the volume might be. Okay, and so in all what we've been trying to do here, not only with the sensor that senses a little bit more sensitivity to gas, we're also trying to get rid of any of the concerns that the regulatory companies may have with just the due diligence of how we report this. Okay. So a little history of where we came from. We adopted a technology from the Canadian Space Agency. There was about $40 million spent on this sensor. It's called the MOPIT program, and it actually was mounted on the Terra satellite that was orbiting the Earth. The sensor itself was looking at CO2 and methane gas emissions and its accumulation in the atmosphere. Our president, Adrian Bannica, was involved with that Canadian Space Agency, and he made an arrangement with them, and we basically purchased that technology from them, and we spent about an additional $9 to $10 million currently right now, bringing this down to a size that's usable in the field. So we had to develop it to the point where we could mount it safely on a helicopter and fly it. The initial size of it was pretty big. They had to do a lot of new design work on the optics to get the light to focus up on the sensors, and then the sensors also were a patented technology. So we've patented that sensor. So there's been that much spent to date. They started in 2002, so they spent about the last 8 years developing this. So taken quite a bit of time to get it to market, but we're right now at the point where I came on board. I was actually currently with Spartan Controls, and for 20 years I was a sales manager for this field sales force, and I'd retired a couple years ago, and I'd actually invested some money with these guys and went in just around Christmas actually, and just to see if their doors were open, which is always a good thing to do if you've invested in a company. And this opportunity to sell came up, so I'm actually quite excited about the technology. Okay, this is a look at what the sensor looks like. That red or that orange capsule right in the middle there. Hopefully you can see it fairly clearly there. That's the RealSense sensor that we've developed, spent a bunch of time developing. Within that box, this whole box here, and you'll see it in the next picture how it mounts up on a helicopter. Inside there we also have a visible camera that's taking visible pictures as you move along. We've got a thermal camera that is using a current technology, which you're probably familiar with, FLIR, I think is what it's called, for looking at thermal imaging. We have a laser altimeter in there, global positioning system, and we've also got an INS system, an inertial navigation system, which helps us compensate for any movements in the helicopter if it sways side to side or if it does any weird movement while the pilot's flying it. We compensate for that to make sure that we stay consistently on the flight path. Okay. In this picture, what we have here is you see it mounted on a helicopter, so you have a relative size to what it looks like. It's right there at the back. So we've been certified to fly on that style of helicopter. That's a Bell 206. As you're probably familiar, may or may not be familiar with, but in working with the Transport Canada, it took us about a year to get certification to be able to mount that on any Bell 206. So we're going to be looking for other helicopters we can mount it on, but right now this is the unit that we fly on. So our plan to go to market here is we're not selling the sensor and we're not actually looking to get into the helicopter business. We're prepared to line up with either, if any customer has an existing helicopter company doing their surveys, we will line up with whoever they ask us to line up with, or if they just ask us to do the whole service, there's a group of helicopter companies that we will fly with. The pilot, as you'll see, has got a pretty straightforward system that we've provided him that helps him understand where he has to fly the helicopter. Okay? So again, we fly at 1,000 meters. Our field of view is 200 feet, so 100 feet on each side of the pipeline as we're flying along. We can sense gas. Definitely, we're not looking at a sub-effect of the gas leaking. Our leaks right now, although we've sensed them a little lower, you can see here in this one test that we did here, we were down at 400 standard cubic feet of methane. You can see how it showed up. We're specifying that we will sense 500 standard cubic feet per hour of methane, which is about 8.5 standard cubic feet per minute. So fairly small leaks. Okay, now this next slide it's kind of one of the customers that I was talking to actually pointed this out. It wasn't part of the design originally, but it was just a factor that he brought up about operational safety, so we thought we'd include it. Right now, as far as we understand, all the surveys that are done at low level. They're done between 100 and 400 feet because they either have technologies that have to fly through the gas to sense the gas, or they're down that low to be able to get a good reading. They're flying the lines visually. And we fly at 1,000 feet. So one of the things, I don't know if you're familiar with helicopters. I wasn't familiar with this. I always figured if the engine quit, you're done. It doesn't matter what altitude you're in. But as I've since learned, that there's a auto-rotate, they call it. If you're up higher than 400 feet, you have the ability, the pilot has the ability to, as helicopters fall to auto-rotate and do a safe landing. And this is coming from the I guess the helicopter community. If you are anywhere between the 40 and 400 foot range, if you lose engine power, it's a pretty severe crash. There's usually fatalities involved. If you're under 40 feet, then you've got still a pretty hard landing with some injuries. So when we became aware of that, when our customer made aware of that, we thought, well, it's another benefit that we have. We fly at 1,000 feet, so whether it's just for the pilot himself and our technician, or whether it's for a customer that might be riding along, I think it's a significant point.